Hi, it's Mr. Bennett here, and in today's video we're going to be looking at introduction to investments and loans, what you're going to be doing in this topic, and then we're going to do some examples for compound interest. So, opening problem you'll find in your textbook looks at Kylie. She's got a job, she wants to actually save some money for a car, and then she wants to better learn to or work out if she can actually afford to pay that car loan off, and then she goes on to looking at borrowing money to save for a house and so on. So, have a quick read of that. It gives you a good idea about what we're going to do. If I just go through this bit over here, so what we're going to be looking at is investing money by saving it. All right, so that's the first thing we're going to do. We're going to be looking at using simple and compound interest. And the key thing about this, it's a once-off deposit into the bank account. All right, so that's the difference between that and looking at making payments. Now, what we'll do this year compared to last year is we'll look at the effective interest rates and we'll account for the effect of inflation on your money, on your savings. All right, so that's something we'll be doing. The next thing is we'd like to look at is saving deposit for a car or a house, and that's the same calculations that you will need to know how to do for your superannuation. And the key thing there is we're making regular payments, so you might have a regular deduction made out of your pay. Right, to do that. Now, the next section we'll be looking at is repaying a loan, right, or an annuity, and we'll be doing that by making regular payments like monthly payments, fortnightly payments. Now, the key thing about that is we want to look at investment strategies to try and reduce the amount of interest that you pay. All right, so that'll be good. And then we're looking at interest-only loans, very popular for investors today. Right, we only have to pay the interest on the loan, not the principal off. Good investment strategy, and then we'll be looking at sinking funds and how they work. All right, so let's just get into a little review of what you did last year. So the simple interest formula, the principal, the rate of interest, the time in number of years. So all you're doing is you're solving for values of I, P, R or T. And with the compound interest formula, you get your future value, your present value, your rate of interest, and the number of payments. And again, you're solving for each of those values there. Now, last year you would have used a formula and did it by hand. This year we're going to be using a graphics calculator. So if you don't have a graphics calculator, you're going to need to order one pronto, and you can see your teacher for a sheet to do that. All right, so when you go to your calculator, you need to press the app button there, and that'll bring up the screen. If you press number 1, you'll get to the next thing, and we're going to use this for most of our calculations this year. So number 1 again will bring you to this screen here. All right, so when we come over here, just explain what they are. N is the number of payments that you make in total. I is the interest rate per annum. PV is the present value or your principal, how much money you're putting in. Now you'll notice that value there is minus 1,500. Because you're putting money into the calculator or into the account, it's costing you. So every time you have to put money in, we call that a minus value. Right, that's what the calculator does. PMT is the payments that you make on a regular basis. So in this first topic we're going to make that 0. FV, the future value. Right, so that's how much your account's going to be worth in a certain period of time. Payments per year, compounded per year. So that's the number of times it gets compounded per year and how many times you put it in. Right, generally they'll be the same, but they don't have to be the same number. All right, and we'll show you how that works. All right, so when we go through these exercises, and exercise 5B1 through to 5B5, they're all using compound interest formula, and all you're doing is solving for different values of P, V, I, N, etc. All right, so let's have a go at this first questions from exercise 5B, number 1, question 3. So we want to compare the investments, the interest paid on the following investment. You're going to put 25,000 into an account that pays 6% per annum for 5 years. So if we did it with simple interest, that's what it's going to work out. 25,000 principal, interest is 6, the rate of interest is 6, and it's for 5 years. That gives you $7,500. Now if we go to compound interest, then that's what it works out to be. I'm going to show you how that works in the calculator so you have some idea how to do this. All right. So the first thing is, we know it's 5 years, So we're going to go 5 times by 4, because it's 4 payments per year is 20 payments. Our interest rate's 6%. Our present value we're putting in there, it's going to be minus 25,000 because we're actually putting the money in. Our payments, now it's 0. Now we're doing 4 payments per year. Now just watch this. The compound per year changes to be exactly the same amount. Now we want to work out what the future value is. So the future value is simply going to be, we'll work it out. So what you have to do is press your alpha button. All right, see it's got a flashing A there. And then you go enter, it actually works it out for you. All right, so that's all you have to do now. You'll need to write down all of these values. So in case we don't, you haven't entered it right into the calculator, then we'll know. We'll better give you some marks for that. All right, let's go back to our PowerPoint. Right, so if you did that first one, it works out to be $33,671.38. So therefore, anything over $25,000 is interest. So that's $8,671. And if you do the same thing over here, for the second one, it's compounded monthly. So that's 5 years times 12 is going to be 60. 12 payments per year, that's the only thing that really changes. You get about an extra $50 in your thing after 5 years. Obviously, the more regular you actually compound it, the more money you're going to make. Alright, in exercise 5B3, we're trying to work out what the present value is. So this is the amount of money that you need to invest now to grow to a future value. Alright, so let's look at this example. You've set your sights on buying a car costing $23,000 in 2 years' time. Your bank account pays 5% compounded semi-annually, so in other words 2 times per year. How much would you need to deposit in order to be able to buy your car in 2 years' time? So 2 years times by 2 payments per year is 4, interest rate's 5, our future value we're going to have is 23,000, payments per year is 2, and we want to work out our present value. So what we need to do there is we need to move our up to PV, press that alpha button, and then enter, and that will work that out to be $20,836.86 is what we'll need to put into our bank account for that to grow. Alright, the next example, 5B4, we need to calculate the time period required for the money to grow to a future value. So your parents give you $8,000 to buy a car that you know costs $9,200. You deposit the money in your bank account, 6% compounded monthly. How long will it be before you can buy your car? Well, so we're going to work out N. So we know I is 6. We know we're going to put 8,000 in, so that's going to be minus 8,000. Future value is going to be 9,200, and we're doing 12 payments per year. So therefore, we go up to N, press our alpha button, enter. That works out to be 28 payments. So that's about 2 1/3 of a year. All right, so it's going to take a while. Now, in reality, we'll be looking at that as being a calculation where you put regular savings into an account that earns interest as well. So not just putting a deposit in there, but we're actually going to be putting regular payments in. So that's actually a more realistic scenario. Alright, the last one I'm going to be doing today is looking at working out the interest rate required for money to grow. Alright, so a young couple invest $9,000 in an account where the interest is compounded annually. 3 years later, the account is worth that much. What interest rate have they been paid? So again, we know N's 3 because it's 1 payment per year. Alright, we'll put $9,000 in, so it's going to be minus 9,000. That's what it's going to grow to, 10,493.22. 1 payment per year. Move our button up to I, our alpha button. Alright, press enter, and it tells you that they are effectively getting 5.25% interest. Alright, so exercise 5B, 1 through to 5, alright, is a bit of a review of what you did last year. It's going to allow you to get used to using your calculator. The key thing with doing that is to write down all these values in I, PV, PMT, alright, so you need to write those down, what you're putting into there, and then it's just a matter of writing, like in this case you get I is equal to 5.25%, alright, so you don't have to show any more than what you put into the calculator and then your answer. Alright, so you need to move through these questions as quick as possible. I think we've allocated about a week for you to do these. If you get them finished earlier, that's fine. We'll take you on to the next section.